Everybody is talking about blockchain, Bitcoin, crypto, Ethereum, Dogecoin, smart contract, mining, proof of work, proof of stake, and all that. But what are those? To understand these terms better, we first need to know what a blockchain is and how does it work. Hi, I'm Hossein Hashemi, and this is The Address, where we talk about cryptocurrency, blockchain, NFTs, and many more in the simplest way possible so everyone, including your grandpa, can understand. In this video, we're going to explain what is a blockchain and how it really works. Let's dive in. The blockchain concept was first proposed as a research project in 1991 with the main goal to allow information to be recorded and distributed, but not edited. I know you're asking me why and how, but we'll come back to it later. In this way, a blockchain is the foundation for immutable ledgers, or records of transactions that cannot be altered, deleted, or destroyed. Blockchains are best known for being used in cryptocurrency systems such as Bitcoin, but the use of blockchains has exploded since 2009 via the creation of hundreds, if not thousands, of cryptocurrencies, decentralized finance applications or DeFi, non-fungible tokens, and of course, smart contracts. Using blockchains, we maintain a secure and decentralized record of transactions in the new digital era. The innovation with a blockchain is not being digital whatsoever. The innovation here is that it guarantees the fidelity and security of the record of data and generate trust without the need for a trusted third party like a bank or government. So to start, I'd like to use the analogy that blockchain is just like a database. In fact, a blockchain is a distributed database that is shared among many nodes of a computer network. However, key difference between a typical database and a blockchain is how the data is structured. A typical database usually structures its data into tables, whereas a blockchain structures its data into chunks or blocks, like its name implies. Blocks are then strung together forming a blockchain. This data structure makes an irreversible timeline of data when implemented in a decentralized foundation. When a block is filled and added to the chain, it is literally set in stone and becomes a part of this timeline with an exact timestamp. Okay, let's look into a simple block of a dummy blockchain to better understand how it works. Like I said, this is a dummy example, but I promise it'll do the job. Suppose we have 3 accounts and each block time is a day. Actually, a day is a long time for this, but we're making it as simple as possible here for the purpose of this tutorial. Say in the first block, we have 3 accounts, Kate, Jack, and Matt. They start the first block with some money and a few transactions also happen. Say the transactions are as follows. Kate pays Jack $5 million, Jack pays Matt $2 million, and Matt pays Kate $1 million. With these transactions, they end the block with $1 million, $3 million, and $3 million for Kate, Jack, and Matt. And imagine the same story for other blocks with different transactions and accounts, etc. You get the idea. So I'm hoping that by this stage, you have a good idea of what a blockchain is and what goes on in a block. So I briefly told you that blockchains are decentralized. Now I'd like to go into a bit more detail so you understand what we mean when we say blockchains are decentralized. Like I said, blockchain data is not stored in a single database, such as in Google's or Facebook's. These companies have huge data centers all around the world, filled with computers, cables, hard drive, lights are blinking everywhere, and aircons are working 24/7. Millions of dollars are spent to maintain these systems. Like right now, you're watching my video from YouTube because this video together with millions of others are stored in YouTube's humongous database. If you think about it, the reason our data might get hacked or used by big companies or get sold to other companies around the world for advertisements or even used for political purposes is because they are stored under one roof. By the way, don't get me wrong, I'm not saying that the companies I name here do this to our data, I'm simply just giving you some examples. But you see a single point of failure, don't you? What happens if the electricity at the location goes out? What if its internet connection is severed? What if it burns to the ground? What if a bad actor erases all the data? In any case, the data is lost or corrupted. So what I mean here is that if, for example, Instagram servers go offline, there is absolutely no way you can access your Instagram data because the Instagram database is centralized. Now what if we change the whole system and store thousands or millions of copies of the data scattered around the world. This is what we call a decentralized system. In such a system, there will be no way to cheat, hack, or steal the data. But you may also ask, I now understand that blockchains are decentralized, but why can no one change or cheat in this system or steal money from it? Let me explain it more so you understand what I mean when I say no one can cheat in a blockchain. Again, I'm giving you an example so you can understand and digest it better. Think of a blockchain as a poker game. This is a different poker game though. The big difference here is that in our poker game, everyone records the results of each hand in their own notebook. Say we have 10 players, so we're going to have 10 notebooks as well, in which players record whatever happens in the game. Therefore, nothing is missed. Everyone can see what you're doing and what you're writing down. So when the full game is complete, all players agree on chip counts and finalize the game. With this transparency, if John tries to cash out $50 more, other players will cross-reference their records and simply decline John's request. Super easy. Because everyone knows how much John started the game with, how much he won, and how much he lost. As another example, let's say that a hacker who also runs a computer node on a blockchain network wants to alter a blockchain and steal cryptocurrency from the network. To do that, they need to alter their own single copy of transactions, right? In that case, their copy would no longer align with everyone else's copy. When everyone else in the network cross-referenced their copies against each other, they would immediately see this one particular copy stand out, and that hacker's version of the chain would be cast away as illegitimate. With these examples, I hope that you've got it already, why cheating is almost impossible in a blockchain system. What I'm trying to say is that blockchains are public and transparent because they're decentralized and distributed across the globe. So, Hossein, you're telling me computers around the world store all the data in a blockchain, right? So every computer works as a node that records everything. Now, what if these computers go down? That's actually a very good question. I'm going to tell you that even if the Earth gets hit by a giant meteor and all computers get destroyed except for one, so if tomorrow morning we wake up to an apocalypse and all the millions of computers out there are destroyed and we're left with only one computer somewhere in the basement of a little building in Antarctica, that only one out of millions of nodes is actually enough to restore the whole blockchain system and get everything back up running. See, we're talking about very, very rare events, which is, to be honest, still way safer than having all your data in a centralized database or all your money in a bank. So in short, a blockchain is essentially a digital ledger of transactions that is duplicated and distributed across the entire network of computer systems. Each block in the chain contains a number of transactions, and every time a new transaction occurs on the blockchain, a record of that transaction is added to every participant's ledger. By the way, the decentralized database managed by multiple participants is called distributed ledger technology, or DLT. Therefore, blockchain is also a type of DLT in which transactions are recorded with an immutable cryptographic signature called a hash. You can let me know in the comments if you like to know what a hash is or how DLT works, and I'll make sure to make a video to explain it. Okay guys, that's it for this video. Thanks for watching. If you learned something from this video, please like it and subscribe to my channel. This means the world to me and will give me rocket fuel to make more videos so we can learn together. See you next time.